Next. Okay, before the break, I'll share my screen. We started putting together 3D version and talking about how in Unity, that's just an expansion of the 2D. Our UI still looks essentially the same. We might need the spinning control. That wasn't really needed in 2D, which is on a regular mouse that you right click and spin around. We still had our rigid body and colliders, just like we do. There's a combination of them in 3D, but you'll want to play around with that because there's a lot of things are set to defaults and we don't have control over them. So it works in a lot of situations, but sometimes it kind of falls apart. You might want the control back and just go with the components that are combined in that thing called character controller instead of the combination of them. That we have control over everything. And we saw the Cinemachine free look camera where we're controlled with our mouse, moving our mouse around to choose different orbits of how the camera is looking at and following our character around. But right now there's no following because our character doesn't move. All we can do is look at it. So that's the next thing to add in here. And it's going to be very, very similar to what we saw for 2D. So I'm going to come up here and create a new folder called scripts, just to keep things organized. This is a small example. We would probably be able to see every file here without putting them in separate folders. But I want to go ahead and express the point about organization because games get very, very large very, very quickly. So it's good to keep organization in mind the whole time. So this time, what we saw before, we could go to our object. I'm going to collapse that parent-child thing there so I don't accidentally click on the wrong thing, which is just a separation. We have an empty object that has all of our game logic, the physics, the collision detection, the script's going to be attached to it. We could add component, create a new script here. And then our image is separate so that when we have a better image, we just get rid of this original image and load in the better image. Just a separation. And once it compiles, the optimizer components of the compiler will notice that those can be combined into a single object. So at runtime, it would be no different than if we didn't do that. So that is purely for your benefit, and it is a huge benefit. So something you might want to keep in mind. So we need a script to make our character move. Because once again, that's something that's going to be unique to every game. So it's not really, it's kind of difficult to generalize it to components here on our interface. We want to do it with the script. So I'm going to click in the Project Explorer and create a new C# script. And I'll just call this player. Or movement, or I'm just going to call it player to keep names consistent because today it's pretty much going to be movement stuff, moving around the screen and then moving between scenes or levels. Scenes is the term Unity chose for it. But Wednesday, we're going to expand this, and then next Monday, we'll expand it more. I'm still a little in the air on the expansion. So there's a lot of ways we can go with it, right? We could set up like the wrestling style fighting games, add in a bunch of fancy animations to make the Mortal Kombat stuff off different key presses, or do a role-playing game with data things. That's what I'm thinking. Almost a trivial example of those things like hit points and experience points, skill level, and that sort of stuff to express the point of how that is almost identical to what you would do in business software. Like thinking about it logically, it's going to be putting together hit points and experience points and all that is going to be very, very similar to logically putting together maybe a payroll calculator that has to keep track of pay rates, hours worked, and days off, and vacation time, and tax brackets, and all of that stuff for a business setting. hopefully you can see that that sort of data control will translate right over to the data about a game object. That's why we haven't looked at much of that. So I would like to see that somewhere, as opposed to just more of the animation things. But there's a lot of different ways we can go, and I've got a couple different things. I've done a couple different prep runs, so I'll probably actually decide that Wednesday morning right before class. But I'm kind of leaning towards the something trivial like hit points and experience points, so that like we can't go to the next level until our experience points get to a certain level. And a trivial example where we just increase experience points by collecting coins. I guess that would make a story almost like instead of experience points, it's we have to collect coins and buy our way onto the next level, as a generic example of that. But first, movement. Yeah, we have to move first. Don't need to think too far ahead. So got this set up and we just want to connect it. So we saw before, you can add component and just search for the name, what you want to name your script. And if you can't already find it, there's an option to add a new script for the component, or you can create it like a normal file and just drag it over here to connect it. So now that script is connected to the player, just like we saw before, and open this up in a text editor. I like to use regular text editors. We talked about this on 2D stuff. That way you don't have to wait for it to compile twice. If you use Visual Studio, you'll have to wait for the Windows compiler to run, because C# is Microsoft's language. So it's kind of, they anticipate that you want the Windows compiler on it. But Unity's cross-platform, so when we get back to Unity, we have to recompile it anyway. I think that's really otherwise, that's the big selling point for text editors over Visual Studio. And for class examples, I have the predictive text turned off, because obviously that would get in the way of you all seeing what's on my screen. But it's you can turn on the predictive text comes from the language, not from the IDE you're using. So you can turn that on in the text editors and get the same predictions that you would see elsewhere. I just turn it off because it would get in the way of the screen. And once again, I'm going to label these closing curly braces, which is kind of like setting up those folders at this point. It's trivial here, but scripts will get very complicated very quickly when we're not under tight time constraints, classroom examples sort of scripting. So it's easy to lose track of the curly braces. It's good to keep up on them. Actually, even with the labels, one of the things, when I did the collision method, I accidentally put that inside of the update method when I was getting ready for this. So it's easy to lose track of the curly braces and stuff. So labels can be useful. What is this? In player class. Something to tell what closing curly brace goes with what. And we still have our two methods like we saw in 2D. Our start method that runs one time to initialize everything. And then one of our update methods, I'm just going to go with the basic update that it happens every frame. We also have the option of late update, where we can make sure that the stuff that happens the very last things to happen every frame of the game, or fixed update that regardless of the frame rate, it happens at a fixed time interval over and over and over again. I'm just going to use the regular update here. And just like we saw in 2D, we can set up a variable for speed. So floating point data. So tell the computer, the CPU, okay, give us room to store a floating point number. We're never going to keep track of what the CPU calls it when it sticks it over in RAM. So we'll give it a useful, meaningful name for us. And we can assign something here, but it can be better to have that assignment over on our interface so that we can adjust it at runtime and hone in on the values we want. And to get it to show up on the interface, we can just say explicitly state that it's public. In C#, public is always implied, but if we explicitly state that it's public, it will show up on the interface. We'll fill that value in a moment. is to access our laws of physics, we use that rigid body component. And well, we want to move our character, which means we want to adjust the transform, but we're kind of trying to simulate a real situation here, right? We want our games to have a touch of realism, even when it is the trivial, like this background that I did in 45 seconds and a character that only has 2 animations, maybe 3 animations. I can't remember how many I put on there, but only a couple animations. So a long way from finished, but we still want to see that stuff. So if we use our physics component to access our transform data, we have all this stuff down here under the info list. The velocity, or linear and angular velocity, inertial data. Inertia is like a force over time. The standard example, since physics wasn't a requirement for this, is when we come to a stop, right? If you're driving along in a car, that car is a big, heavy object. It's going to take a certain amount of force to stop that car. But that force can be applied in different manners, in particular over time. So a force applied over a time interval is inertia. Sort of the difference when we stop a car, we could bring a car to a complete stop by hitting a brick wall or by hitting a row of bushes. And obviously to stop that car, it's going to take the same amount of force. But if we stop that car by hitting a brick wall, it's going to total the car, right? Whereas stopping that same car by hitting a row of bushes will probably barely scratch the paint. That's what inertia is. It's that force applied over a time interval, spreading the force out. So we have access to that and the center of mass on our thing. And we have all the laws of physics that we're used to, and some that we don't even have control over because they're really, Unity has a really, really nice physics engine. So they don't even give us access to the friction and they give us minimal access to the friction and air resistance and all of that stuff. So if we use that to access our transform, then we get all those values worked in. So it's going to seem a little bit more realistic. Things don't suddenly stop. They have to come to a stop if they're moving. Yeah, and that subtle bit of realism is quite noticeable. So instead of accessing our transform directly, it can be a good idea to access it. We'll make it private because it won't be needed outside of our script. Nobody needs access to that except us. And we'll call in some rigid body data, which I am constantly trying to do that with a capital B. It is a lowercase b. They did it as one word. And then we need some sort of name to refer to it by. I'll just call it player because that's what we're referring to. And the point I always like to express is these words right here, they only look the same to us. A computer will never get those confused. Nor will it get confused with this word player over here. They only look the same to us. Those are reference values. The computer does not use the reference value at all. Only the human does. To the computer, those are all binary numbers, different binary numbers. So the computer, they do not look the same to the computer. But similar to what we saw in 2D in C# syntax, a speed that we're going to move, and then that physics component that we want to access all of our movements through so that we get those things like friction and momentum and air resistance and water resistance, and all those, the movements seem a little bit more realistic that way. Unity has a really nice physics engine. We don't want to bypass it and go directly to our transform. Would be a short way to say that. And just like we saw in 2D, these are all components of our game object, so we can access them from that script that's attached to the game object. So our player will get in the exact same way we got it in 2D. The only difference is the type of data, which isn't even that different, because in 2D we used rigid body 2D, and for 3D we want just a rigid body type of data, not the rigid body 2D data. Do you have any other notes here about that? Oh. So that should look very familiar. Nothing different from 2D there, really, except for that trivial case of the number 2 showing up in some of the data types. Our input's the same. We're not using a different keyboard. That was external to our game, so we'll get that in the same way. We have a floating point number for a horizontal value that we can ask our input manager for by saying get axis. And then we have lots of axes we can get. I'll remind you where they're at. Under the edit menu and project settings, you see all these things that are just, again, the UI is just accessing the same libraries we're trying to access from our script over here. So there's all these different things, the quality of it, time values, different templates, or this input manager, which has a bunch of axes, including a horizontal and vertical axis. And we want to ask for it by name, which we can change the name, but they gave it a really good name, one that's easy to remember. And we can change which button it's assigned to, but those are kind of the standard, the left and right arrows, or the A and the D keys. And we can just access those that way. And just like we saw before, I guess just kind of a reminder there that all the values we want are probably on that interface somewhere. So try to look there. It might take a while to get used to. It's also a really good way to explore that big complicated interface for this game engine. It's just clicking around looking for the values there. So try to look around there before immediately going and looking things up. It should help you get familiar with everything a little bit better that way. Horizontal and our vertical axis, because we have 2 types of movement. And then we can just use that to make some movements. I'm going to set it up a little bit different here, though. Before we accessed our rigid bodies transform data and then set that equal to some new vector. This time I'm going to actually set that up separately. So we want a 3-dimensional vector data. Last time in 2D, we were using 2D vector data. So this is the one that's the first big difference, which should be trivially obvious, right? We're in 3 dimensions, so we need a vector 3, not a vector 2. I'm going to call it direction, and that'll be a new vector. And then we'll just assign that to the thing instead of doing it directly. Mostly because I want to, in this case, I want to check what that is before we assign it for some stuff that's going to come later. For now, I guess we could kind of get around it. And we'll do that almost the same way, only we have 3 values. We have an X, a Y, and a Z to put in this time. And just a reminder, if I select the player and zoom in on that, hit F to zoom in on something. So our Y axis, which is labeled over on the controls here, is our vertical one. Our X axis is pointing off to the characters left and right. And the Z axis is the forward and backward for our character. So we're just going to move around. So we'll skip the Y axis because that would be a jumping thing. So our Y, we're not jumping right now. So I'm just going to put that as 0. And again, the little F there indicates it's a floating point number. C# is going to try to default to double precision floating point numbers, and games get very large very quickly. So it's still good, even though computers are much more powerful than they used to be. It's still a good idea to save those 32 bits every chance we get in games. And all the stuff in Unity is anticipating that. So all the stuff in Unity is set up to handle single precision floating point numbers, the 32-bit numbers, instead of 64-bit numbers. So you'd have to convert it back to a 32-bit number before using any pre-built methods anyway. So we need our X data, which our X value will do the same way. That thing we got from the keyboard, the input axis, multiplied by our speed, will tell us how far we want to move left and right. And same thing on Z, our vertical axis input multiplied by our speed to indicate how far we want to go forward or backward. Was it? Usually I normalize this, but I didn't in the example. So I'll just leave it like this. Actually checking how far we're going to go. And I want to add a condition in this time. I guess it can be useful. We don't want to just always adjust that every time. Because, well, on the first step, all we're going to do is move, so it won't make a difference there. But as soon as we do that, we're going to come back over here and make our character turn to go that direction. And then have some other stuff to talk about with turning. So on the very next step, we'll want to check and make sure we're moving. Otherwise, the character would always automatically snap back to the world directions if we're not moving. So before adjusting our character, I always want to, it's a good idea to check that. And a word for anybody who's been through like trigonometry classes and started learning about vectors, you would have seen the word magnitude, which anytime we create a vector, that's a variable we have access to stored inside that vector data. There's this variable called magnitude, and a magnitude is the size of the vector. So in the case of thinking about it, well, movement's a good one. We can think about a vector instead of a point in space. We can think about a vector as an arrow in space. It's pointing in some direction, which means it's going to have a length. So magnitude is like the length of that arrow. How big is the arrow? Is it a great big one, a little bitty one? As well as which direction does it point? But we can just, I don't know why I said equal. If that's greater than 0, so we always want to check and make sure that we are moving. And magnitude is always going to an absolute value. Positive and negative have specific meanings when we get into vectors. So our components of the vector can be positive and negative. And the vector itself can be positive and negative, but the magnitude will always be the absolute value of that. It's just how long is it? It doesn't take into consideration which direction it's pointing or anything. So we can just check and see if that's bigger than 0. Well, that indicates we are wanting to move. So in that case, well, we'll just move. Same way we did before. Our player object, which is our rigid body, so it's accessing all the laws of physics, .transform. So we'll access the transform through the laws of physics. Then we get that nice move, and then just give it that direction we said to move. When we did this in 2D, I just took all of this part and put that right here. I wanted to add in that condition. Even in 2 dimensions, it's good to check that first. But I want to add the piece, build up the pieces slowly, because we're trying to build deep understanding, right? Not exactly copy and paste code. There's a lot of that at this level, but understand this stuff. That way you can use it without having to look up something to copy and paste it from. So it should look almost identical to the 2D movement. Oh, whoops. I see a typo on here. That does need to be vector 3. There was a typo there. When we created the new vector 3 data, it is new vector 3 data. I'd left the 3 off there. Could be another typo. I was talking the whole time I was typing, and you all know how it goes. Typos happen when we're just typing. I was doing at least 2 things at once. Oh, there's something there. Property-oriented component transform cannot be assigned to is read only. It shouldn't be read only. Let's just use the overall one. Oh, that was a typo. Did anybody notice I just did something completely different than what we did in 2D and said we did the same thing? I'm sorry about that. I was thinking about the transform because that's just the generic position. If we access the transform, that's the one that it wouldn't have the law, any actual physics. It wouldn't have momentum. If we stopped, it suddenly stops. And things look a little off. Just like we saw before, we're going to use velocity, the vector version of speed. So a speed and a direction that speed goes in. Sorry, that's what we did in 2D. Yeah, I just kind of got a little distracted there, I guess. So hopefully that'll clear up that error. There we go. So no more errors in the project now. And yeah, I said the words exact same thing we did in 2D, but then did something completely different. So hopefully you notice that and remember that we were using the velocity component of our physics to change the position. So I run this, and I always find it's useful to bring the mouse to a good starting point with those type of cameras. I push forward. Oh, I forgot speed, which I was going to stop because I'll keep forgetting that. We made speed public, so I'm just going to pick some speed, maybe 7. We'll see what 7 does. Maybe that's too slow, too fast. Once we see it, we'll have a better idea of what the speed needs to be for this particular character in this world. Okay, so you can see first thing he did is got off balance because laws of physics are applied. So we have things like the center of mass. And that's these freeze rotation. We'll look at that here in a second, but in general, it's still moving. It's moving really, really weird. 7 might be a little fast. You see our camera still works. The character moves around. But the center of mass got off. And that's what these freeze rotation things are about. So we can freeze that. Let me run this again and try to get him to flip over a different direction. We actually want to freeze all 3 of them. But when that happens, right? So now if we start moving forward and backwards, okay. Oh, when I push left, he just does a cartwheel. And now he's laying on the ground rolling. That looks a little more realistic, rolling instead of sliding. But we want to freeze all 3 of these rotations. That way he stays upright the whole time. I always like to see errors. So whenever your character or whatever object starts doing that, flipping over strangely, It probably has to do with the center of mass and the physics and everything. So just kind of freeze the rotation or whatever is appropriate. Then we move left and right, forward, backward. Our camera still moves around the guy. All the things we're kind of familiar with. So basic movement with the camera follow, you can see is very, very quick to set up in Unity and should look almost identical to what we did in 2 dimensions. The only difference from 2 dimension is right here on this line. We had to do stuff with the z-axis instead of just the x-axis. Or instead of xy, we had to do stuff with x, y, and z. But we're not jumping, so just moving. One thing that does look a little strange, though, is when it moves forward, it looks okay. If I move to the right or the left, that looks a little strange. And you just, or backwards. You probably want to face that direction. So we can access it and face that direction. The easiest way to do so, and this is, it kind of has to be in this selection structure, make sure you're moving before you do this. Otherwise, it'll always snap back, try to snap back to the other one. Well, we have this game object itself, the game object that we're controlling from our script. We can always access that from a variable. All we have are a speed and a player variable. But remember, in object-oriented programming, we inherit things. So we also inherited a whole bunch of stuff from this mono behavior object. One of those things being an object or a variable called game object, which is holding the data about the object we're attached to. And like everything in a game engine, that object has transform data. And there's a lot of transform data. We have our position, rotation, our scale. And you kind of see here that with our position, we have the X, Y, and Z, but when we see the axes, they're represented as vectors. There's a direction included as well. So there, along with just X, Y, and Z, we do have forward and backward and left and right. So from that transform data, we can just set our forward, which is a vector, like that little blue arrow there pointing forward indicates it's a vector. Remember, that's how we think about vectors, because they're arrows on our screen. So forward is a vector, so we can assign that the same vector we want to move it. And that way our character will always face the direction we want to move. It's going to look a little jumpy. It can be a lot smoother to go through the trigonometry of finding the new angles and smoothly rotating around some angular velocity to get to a new one. But for starting out, we can just jump to that. It'll happen quickly, but hopefully it'll look okay. So now forward looks okay, but now when I go right, it turns and faces the right or left. And our controls are still world coordinates. This always throws me off using world coordinates, because right now I'm pushing that backwards, but it looks like he's going forward. I generally prefer to do yaw, pitch, and roll. Has everybody heard those words before? Probably in this situations with planes and boats, but yaw, pitch, and roll are the standard terms for rotation in three, or movement in 3 directions, in particular rotation. The one most interested in is yaw. That's rotation around our vertical axis. So normally when we set up controls, it's kind of nice to have our like A and D keys turn the character, and then the W moves forward for whichever direction we're facing. But we do have to do that by controlling yaw, rotation around the vertical axis, which definitely requires trigonometry. So I didn't want to actually do that in the class here because trigonometry is not a prerequisite, but I was going to write out the equation for it. So like store angle in a variable to track current direction. I'll just put it in here as comments. So then our yaw x value, we find that from cosine of our angle plus the turn, and then our input axes, in particular the horizontal axes, controls the turn. So if you haven't had trigonometry, this is going to sound confusing, but for those who have had trigonometry, you'll want to do it in radians. So maybe like pi quarters turn each time or each frame, or pi sixths, or however far you want to turn each frame. Have your like A and D keys control those and add it to the angle you were already facing. And you'll get your two horizontal values. The x, the left and right, is the cosine of the angle you were at, plus that turn, minus the sine of the same thing. Angle plus turn. And I'll go ahead and put it on here as z. Usually we would think of this as, if you saw this in a traditional math class, you would have seen it as your x and your y, but Unity went with z for the horizontal, kept z as a horizontal when they put their engine together. So I'll put it as z here. That is going to be the sine of the same thing. The angle we were at plus how much we're turning added to the cosine of the angle plus the turn. So if you want to do that turn and move, this will give you a new forward every time. Just set it, and you just need a variable to keep track of that angle. Trigonometry wasn't a prerequisite for this, so I thought I would just put the equations in there for those who have had trigonometry and want to kind of work with that. For us here, we'll probably be okay for starting out, getting used to things, just using this. Because then once we have those angles, then we have to use the quaternion to actually rotate our character. I'll put that in those notes. Then quaternion, Euler to move that angle. Yeah. Which is in radians. So anybody that's had trig class knows or recognize some of those words, but you can switch it to degrees. It makes your code look a lot cleaner if you just work in radians, because you need a whole bunch of extra code in order to convert that to degrees. But for us here, we'll just pick a direction. And if that direction's bigger than 0, we'll turn and face in that direction and then move in that direction. Hopefully everything there looks somewhat familiar. I guess this is the new one we didn't see in 2D because we didn't really have multiple directions we could move in. But otherwise, most of that stuff should look very familiar. And hopefully you all are seeing that it doesn't take much to get that started. Oh, Joe disappeared. Gonna wander around the desert thing. Yeah, these world controls throw me off. And there's a little bug there. I'll leave that for something for y'all to kind of work with if you saw it. Notice when I walk over that edge, it stays up in the air until I release my hand. I can show you where that's coming from. When we're in direct control of the movement, we said keep the Y value at 0. So until we release the buttons, the Y value is not going to change. It's staying what it was at the last frame of the game. Might be good practice to try to track that down, see if you can get that adjusted. But it gets our character moving, stationary. We probably want to animate that. So that's kind of the next thing. Is everybody okay? Yeah, it looks like Joe's back in now. I always like to check that. At one point in the past, Zoom has been updated several times. Whenever the screen would be shared and that button would pop up to bring somebody in from the waiting room, all it would do was stop showing me the button. It wouldn't actually bring people in. And I didn't realize it for a long time. I'm pretty sure they fixed that, but it's definitely something that's stuck in my mind. And I always find myself worried about it. So we got our character moving around, turning to face that right direction. Starting points here so we can build understanding. Hopefully that's making sense, and you can see how we expanded that right off the stuff we did in 2D. Animations are going to be very similar. The biggest difference is we animated a 3D model, so I had to do that over in Blender, and we're going to take a look at that on Wednesday, how to set those up with the names and stuff. Right, so there's a jump animation and a walking animation, but just like the backgrounds, I did that really quick, so it looks more like a limping animation than a walking one. And then a waving animation, because that seemed like a nice, easy one to. I just needed a really quick one. That seemed quick and easy at the time. So a couple animations there that we can do. And when we were in 2D, we saw this animation window. That's for the 2D sprite animations. We drag in that two-dimensional frame and then the frame by frame by frame. But we already have all of that defined here. Right? That's why the preview window already works. That was already defined for our entire model. And we saw earlier it goes with the armature in Blender. We'll look at that again for review on Wednesday. And how to set them up properly. Because last time we just kind of split it up amongst the frames. But we need to set up our dope sheet properly and give everything names there so that we can bring them in. Once we have the animations, we control them the same way. We need an animator controller. So I'll make a new folder for that. Create a folder. Again, it's important to keep things organized because games will get you'll end up with lots and lots of files very, very quickly. Right? There's almost nothing here. And we've already started getting a few files, adding up. So just like we saw for the 2D animations, once we have that frame by frame animations, we need an animator controller to keep track of it. The same thing, we have our 3D animations, so we need an animator controller. We go to create an animation and a controller. I'll just call this player again. And naming the same thing, using that same name everywhere. I could even rename this one to like player graphics. Use that word player everywhere. The computer won't get that confused. Those are only human references. The computer does not use that word. So we can reuse that word instead of trying to come up with something useful in different situations. Then once we have our animator controller, we'll bring that over and attach it as a component to our game object. Which I should collapse and remember, do it on that top level object, that separation between graphics and logic. I forgot to bring my bring a cover down or something to cover the window. So there might be a glare here in a second, but since everything today is on a screen share, that really won't matter. And we're almost finished with today's stuff anyway. So once we have that, it's going to control our player object. We'll just open that up and you'll see we kind of have the same little thing. We have the starting point, and then we'll transition to one of our animations or any state. So no matter what we're doing, we can set up a transition from anything to one of our other animations on like a certain key press or something. And then the exit, the actual shutdown. So we just need to bring in our animations, and they came with that model. So over in models, if it's collapsed, you can expand it out to see all the parts of the 3D model, including the animations, and we'll just drag these up here. So we have a jump animation, a walking animation, and a waving animation. And right now, since I've drug it in first, the jump animation is set to the default one. I'll make the walking one the default one. So right off the bat, when I hit run, it should play that walking animation, right? But I want to come over here and do that because there is a slight issue. Run it. He's not walking. They're supposed to be walking. So we come over here, and it kind of happens really quick, is why. If I hit run, it doesn't look like anything's happening. And the reason why it did happen, but it happened very, very quickly. It's only a like 15 frame long animation. And by default, it's not looped. It doesn't loop. So we need to make sure that's set to loop. And to do that, when you import the things from Blender, you'll expand it and have the animations. So just choose it. Here's our walking animation. And so if you select it here in the project window, wherever it's at in the folder, when it pops up in the inspector, you'll notice loop time is not checked. So by default, that it's not checked. Because a lot of our animations, we probably don't want to loop, right? Like jumping looks kind of strange when it's looped. Unless we're jumping a bunch, we don't want that to happen repeatedly. But our walking, we want to keep happening. So with it selected, there's this edit button. And if you scroll down, you'll see the checkbox for the loop time. And for these, since we're adjusting a file, we're adjusting an external file and not doing something in Unity, we do have to scroll on down to the bottom and hit the apply button. There are a number of places where that'll happen. So just remember, if it's an external file, make sure you remember to apply the changes. Oh, I just put that on the jump animation. I do not want to loop the jump animation. I want to loop the walk animation. Sorry, I guess that was pulled up because I had just selected it. So make sure you're on the walking animation and hit apply. So now it should continuously loop. Uh-oh. Oh, I think I put that in the wrong spot. Hopefully what went wrong kind of makes sense in your mind. I attach that to the logic thing, but we have that separation of logic and graphics. Which one should the animation be set to? Hopefully that question seems obvious, right? Because an animation isn't logic. It's going to relate to our thing. And pictures are in my way again. But we're going to want to access that from the script, which will give us a problem, right? The script is attached to the logic side, not the graphic side. So that's what that second option there is, the avatar. What are we actually animating? And that would be our graphics. Oh. That's not going to let me bring that in, is it? No. So I'll put that on the graphics instead of here. So we don't need it in our game component. I'll take it off there. And on the graphics, that's where we want to attach that animation. Like that, and drag it over here. So now if we go in here, it's the same one we just started working with. Just move to the graphic side instead of the logic side. You see that walking animation starts immediately. And as we move around in different directions, our character actually looks like he's walking now. And flying periodically. And setting that up, adjusting those will be the same as we saw in 2D. We would just set some sort of parameter, and then we would adjust that parameter. A Boolean or a floating point number. I'll use a floating point number because we saw a Boolean last time. I'll call it speed. And I'll just put in some number. So I did something different. I need to access it from here. I can't remember the syntax. I did it something different than what I did in my example, which is going to throw me off. Can I set up a reference to this here? Nope, that would give me something different. Well, I'll do this. There is a way to explicitly grab the child object, and I can't remember the notation. So I'm going to walk through a process of, instead of looking it up, using the pieces we know, because we've seen a bunch of pieces now. It's like, oh, I can't remember the notation for that. I could go over to online and look up the shortcut, but there are some things I know. Like, I know that's a game object. So I could just create a public reference to a game object and call it graphics. And then when I come back over here, using things we know it's a game object. And if we make it public, then we can assign it over here on our interface. So go to player, and now we have a spot for that script expecting a game object, so we can drag that game object over there. Instead of going and looking up the notation for the child objects and how to access that, I'll just make a new spot and drag it right over. I'll make my own way to connect it since I can't remember the notation for that. So that's assigned. So now we can access all of those things about it. Which is going to take a couple steps, because just like we saw last time, in order to control that, we set our animator data up with this speed parameter. So we'll need an animator over here to grab that. And we can do that in a couple steps. Sort of the same thing, only the component I want to grab, the animator component, is actually over in this other game object. So I want to look at that to call the get component. Does that make sense? So there is a shortcut to do that, some notation built into Unity, but I couldn't remember what it was. But I do know enough to find that data, because I know everything's a game object. So I can just set up a spot to reference that like I would a number or any other thing that can drag over to that spot, get a reference to it. And then for my animator data here, I can just use that reference to call the get component method of the thing over there. And then check and see if that threw an error, if it disliked that. No error messages. So it didn't immediately crash doing it that way. And then we can control our changes using that variable. Hopefully that made sense. So let's make a transition going from our walk animation, and we'll just use the wave for the idling one. And make a transition from the waving back to the walking animation. And just like we saw before, once we set up our parameter, we can choose that transition and do little adjustments like change how long it takes to switch between them, and little refinements there, which best way to learn those is just mess around with it in lab time. Make a change, see what happens. And when we're ready to change, we want to use our parameters. So I'll go from walking to waving when speed is less than 0. And then go the other way, from waving back to walking when speed is greater than 0. So obviously we could tie it to this value right here. That would be one way to do it, or we can just check it directly. I'm just going to manually adjust it here. Instead, we could just compare it to that value, but really all I wanted to show, what I wanted to show can be handled by just changing. So if our magnitude is bigger than 0, that means we are moving. Then I'll do the same thing we did before. grab that animator data and use the set float method. It's on my mind. Last time we saw set Boolean, so I wanted to show that the method for any of our data is the same. We'll use the set float method and set that speed parameter to something bigger than 0 because we are moving. It doesn't really matter because all we're checking is it bigger or smaller than 0? So something bigger than 0. But if we're not moving, then we'll do the same thing. We'll call that set float method on the animator and set speed to something smaller than 0, like -5. It's a floating point number. We could have gone with positive and negative 0.1. Anything that's not 0, as long as it's above or below 0. But it's almost identical to what we saw last time. Probably a better idea to put this number here, and then that way we're always our speed is the same as our speed here, essentially. But either there's different ways to do it. I just wanted to show the set float method as an indicator that whatever our parameter is, oh, missed a semicolon somewhere. There it is. Whatever our parameter is, once I can click on the arrow, there it is. When we go to create a new parameter, it doesn't matter if it's a floating point number, an integer, a Boolean, or a trigger, we have those get and set methods that look exactly the same. We pass whatever we called it in as a string, and it's case sensitive, so watch your upper and lowercase letters, and then reassign the value or access the value. So that should switch between our animations. Oh, that animation's not looping. Well, I'm going to set up the loop again, but that's something we have to do every time. So maybe review. So we're walking, we stop walking, and we go to wave. But I guess there we saw it. We didn't see it really earlier because it was right as the game loaded. But the animation only ran one time, which is what they're going to do by default. So to change it, go to your model where you brought that animation in with, and select the animation here so that it shows up in the inspector, and hit edit, and just hit your checkbox for loop time. And we're modifying an external file, so we have to hit the apply button before it actually happens. So now we should see our waving animation, which I guess works for the desert. We're not moving, it's just kind of waving. I did that animation before the desert scene. I guess it kind of works for the desert. It looks like, oh, it's hot, trying to create a breeze or something. But that was just one of those happy little coincidence things. Yeah, see if you can figure out what to do on that bug. That'll be really good practice. I'll even show you which numbers is throwing that off. It's this 0 right here, the Y value in our direction. See if you can come up with something that would fix that. There are lots and lots and lots of ways to do it, and thinking that through will be really good practice for you. So, what time is it? 3:17. There's one other thing I wanted to do, which I think will go kind of quickly here. I'm starting to get a glare on all my screens. So I think this will go quick, and then we'll wrap it up. So I want a way to go to more than one scene. By default, there's one scene. Oh. So maybe rename that as desert to keep track of what scene it is. Let's reload it. Uh-oh. Whoops, I just erased a bunch of stuff. Okay, so I got an idea. Remember not to ignore boxes that say, do you want to save? Like I just did, because you'll notice everything we just did is gone. But I prepared for the lecture ahead of time, so I'll just go in and grab the grab a different one. This one will work. Sorry, I have no idea what I was thinking there. Don't ignore boxes that recommend saving or that tell you something hasn't been saved, because you might accidentally erase a bunch of work. In this case, an hour and a half of work, and I haven't hit save yet. Some of our game engines will automatically save before we run it, but Unity will not. So let me delete some stuff from here. So scenes. So the desert scene, this was practice. This is set up almost exactly the same. I'm gonna delete the other scene. Yes. Yeah, that'll be fine. And models, I'll delete that, bring that back in. Okay, so now I'll hit save, and this should be very, very similar to what we just had. So our character is waving, we walk around, starts waving again, keeps waving, walking or waving, kind of like we just saw. Oh, I don't have the nested graphics, so that's a little bit different, but it's essentially the same thing we just saw. Sorry about that. Try to get this last step in here real quick so that we're ready to expand on this Wednesday. So it'd be nice to have another scene we can work with. So over in the scenes folder, kind of the same thing, we can right click, and under create, we have an option to create a new scene. And because I drew another model for it again, I'm just going to call it swamp. And we go over here and you'll see we have a completely empty world, and I didn't accidentally delete everything this time. So yeah, can't believe I just did that. But anyway, luckily had a copy of it. Just remember to hit save things along the way. So we want to be able to get to this other scene. So in models, there's the desert. Then looks like I have a couple versions of our character data. And one of the things I sent out was a Blender file called Swamp. And just like we saw, we can just drag it over. Or if you right click, there's an option to import assets, and you can navigate around and find it. But when we bring in the Blender file, it will automatically convert it to an FBX with only one animations allowed though. unless you go change the Unity source code. And it's a clearly labeled Boolean that you just change to true or false. So now if we go to our other scene, just like we did before, we can just drag that model in there. So again, it's something I made really quick. I just grabbed a cube, stretched a few things upward, hit them with the chisels to add clay and smooth it out and cut some ridges in it and stuff to rough up the surface, I guess. And then added another cube that was blue to look like water and just kind of nested it inside there and then combined them into one object. Did not spend a lot of time on it. There's a couple things that we want in common, right? Like we want the same character. We don't want to have different controls when we go to a different layer. So I'm gonna go back to the other scene and just copy that over. And I'm going to click yes, save it this time so I don't lose anything. So the player object's a little bit different than the one we just made because I did that better form of separating the graphics and the logic than I did when I was doing this practice run. It's labeled as the second practice run, but it's really just because I couldn't sleep last night, so I got up and did another one. But I'm gonna come over to this scene and hit Control C or Command C or whatever machine you're on, the normal copy feature. Then if we go over to the swamp, we can just paste that right in. I should have done that from a right click. That way y'all could see which buttons I hit. So all I did was just a copy paste. And now we have that same object over here. So we just need to position it somewhere good for this scene. Probably over some land. Oh, looks like he's down below things. So let's drag him up above the land. And yeah, you can see whenever it starts to overlap. So I would like to usually just leave it a couple inches above so it'll fall down, but I'll accentuate that here and raise it up a little bit. And then whenever the game starts, or whenever this scene starts, he'll fall down. And then just like we saw for the desert, so that he doesn't fall through it, which I guess I could go ahead and do because we copied and pasted that. So he has those laws of physics applied. It's like the camera's in the wrong spot, but we're underneath our scene and we can see gravity applied and he fell right through the land. So I'm going to select that. And there's different options for complex ground with the collider. I like to go with the mesh collider that just matches it exactly. And on the players, I'll use a box or a sphere or a capsule or something where there's room outside our player. That way we can have collisions happen when we're near stuff, not just right on them. So now should do essentially, well, fall down and hit the ground, stop moving when he hits the ground. But I don't think we can see it from this camera. And the Cinemachine camera, when we copy and paste those, they'll act a little funny sometimes. So unless you spend a whole lot of time adjusting it, it's probably quicker to make a new one. I'll just make a new free look camera, the same one, so it's a good place to review it. We're going to follow our player. We're going to at least follow and look at. So we're going to follow and look at our player. And then if we scroll down to get our orbit numbers, I'm going to come over here and copy the ones from the other thing. So yes, save this scene. Notice our scenes saved differently from our game. We're saving each level independently. So on the camera here, those orbits were set up as 8.4.3, 2014, 6. Now I'll go back over here and let's see, 8, 20, 4, I think that was like a 10 or something, 0.3, maybe 6. I forgot the numbers, but it was something close to that. I was trying to get them typed in before I remembered it. So now we should have that same camera set up, and we copied and pasted our character, so it should move the same and everything. Oh, we can see the animation kind of stopping there. We start to walk around. Get that same turn and walk stuff that we had before. And the animations, so slightly different than the one we were doing. When I do the prep work, I don't do the exact same thing. It's just kind of a rough review. And then we hit that problem where that separator we had to actually think through a way to get this component instead of doing that the other way. So hopefully all that made sense. The last thing I wanted to get in here today is a way to get between the scenes, because we did not see that in 2 dimensions. So I'm going to start over in the desert. Yes, save this one. Don't need to be deleting work. And I'll go somewhere near the player. Where's our player? There he is. Maybe turn this way. So right over here near the player, I'm just going to make a new object. A sphere will work. Maybe not that close to the player. I'll move it back just a little and give it a good name. So rename that as gateway. That's what it is. It's the gateway to our second level. And we'll just set that up as a collision, because our character has this box collider around him. And this, well, when we brought in the sphere, it automatically had a sphere collider, which is exactly on the sphere. So I'm going to stretch that out a little. Oops. Yeah, I'll just stretch it out so it's a little bit bigger than the original sphere. And that way the box collider around our player and the sphere collider here, they expand. So it's just when we get near that thing, it's going to trigger something to happen. And the thing we want to happen is already in this script, so I have to delete it so I can talk about it. Delete that. So we want that to happen when we get a collision. And those are built into Unity. In fact, they're built into this thing we inherit from. So they're already being called almost every frame of the game. So what we need to do is override that default one that doesn't do anything and say what to happen when a collision event occurs. So it's a void method. It doesn't send anything back. It just does some stuff. And the name of it is on collision. 2 L's, 1 S. I have spelled that wrong so many times. And then we actually have 3 of them. We have on collision enter, which is when we first make the collision, when that first incident happens. On collision stay, which is the entire time we are colliding with it. So things that happen repeatedly, or on collision exit. I'm just going to do enter. As soon as that first collision happens, and we're overriding a method here. We're not creating a new one. So we have to match the original one. So when that collision happens, there is a type of data in Unity called collision that will be passed into this method. So I'm going to give the reference name, the variable, sort of the same name. So we'll receive some collision data and just call it collision. Oh, okay. Yeah, there was a note in my thing here to run and see a specific error, and I was very vague in my notes. I couldn't remember what error I wanted to see, but I remember what it is now. So we can use that collision object data that gets passed in to check and see what we have, which we're checking something to see what we have. So that's our normal if else structure. And the thing we want to do is this collision data. There's a whole lot of stuff in there. And that's all the data about those two game objects intersecting, trying to be at the same space at the same time. The definition of intersection. All of that data is passed in, including the two game objects. This script is connected to our player, so we can ask for the other game object from the collision. Collision.gameObject is our other one. And then we just need a way to see how we got it. And one of the things I did here is I gave it a name in the hierarchy, a hierarchical name, which when we want to access that from our scripts is the name. So we can see if the game object we collided with is named gateway. So if it is, then we want to go to our other scene. And to do this, we have to import another library. So I'm going to scroll up to the top. Oh, this library, I'll type it in. So our keyword in C# is using. That's how we import another library, or say which libraries we want to use. And Unity Engine, remember we talked about it briefly, that's actually a folder. So in that folder, there's a bunch of C# scripts set up just like the ones we have here. They'll say public class, then some name, maybe they inherit from stuff. But there's a bunch of those. So if we just say the folder name, we can access all those scripts. But there's also other folders. And we might need to get into those other folders to access scripts. One of them being scene management. So once again, you can see Unity, they did a really good job naming things. All the names should make sense, right? Our collision stuff was called collision. Our stuff to manage a scene is called scene management. And then there's a bunch of stuff in that folder we can use. In particular, there's a thing called scene manager. Did I do anything special? Nope, just load scene. And that scene manager object has a method in it called load scene. And then we just have to say what scene we want to load. And just like the way in Gateway, every scene has a name, a desert or a swamp. So if we hit that thing, I want to go to swamp. And then there's an error message I want to see. So still one other step, but I want to see what like always, I like to see the error message. That way you'll know what to do when you see it. I gave the thing the same name, so hopefully it's not going to open through it didn't throw the error message. Let me rename that. Well, we're renaming it where we'll call it Swampy. It's probably going to update automatically because Unity is very thorough software. Nope, it updated automatically. Okay, so sometimes you'll see a message that says it doesn't know about the other scene. Well, maybe I'll just make a new one. Create another scene. Call this error thing. I'll call it errors. And then I'll try to go to that scene. How to spell that? It is case sensitive, so you have to be careful with that. So errors. So now it's going to try to go to this scene that doesn't have anything, but I just want to throw that error message to show you how to fix it, because it's a common thing to accidentally do. Walk over here. Oh, there we go. So we got this error message. We're still in the desert. It kind of kicked us back out of the game. So on the console, scene errors couldn't be loaded because it has not been added to the build settings. So once again, we saw this earlier. A lot of the Unity messages are really nice because it comes with a suggestion. To add a scene to the build settings, use menu file build settings. It tells us what to do, but I still wanted to look at it. Whenever we add a new scene, you want to go to File and Build Settings. Then here's all of the scenes we have. So the game knows about the desert scene and the swampy scene, and it already knew about it, so it kept updating that automatically. If we would have had a new version, it would have worked more consistently there. And our button, the only button we have is to add current scene. So to add it, yes, save that. You'll go to the scene that you want to add. And while you're there, go to Build Settings, File, Build Settings, and then Add Open Scene. And then that will put it on there. So now, if we go back to the desert scene, that's a common error message. It's easy to forget that. In a lot of games, we don't have to manually add our scenes like that. You can see it jumps over to that other one, which really isn't much use to us. So I'm going to go back to the swampy thing. How did I name it? I just wanted to show the error message. And well, then to get back over here, we can just make a copy of our gateway and put that in our swampy scene. All the way down here. Paste that. Where is it? And I'm going to put it somewhere close to the player, so we don't have to walk a long way to get to it. You can see there's a lot of navigating around, adjusting your view over and over and over again. Not that close to the player. There we go. That one won't take us forever to get there. And then I'll delete that one that was just there for that error message. So now we have that same gateway in both scenes, so we can check and see which one we're in order to decide where to go next. And we can do that from the scene manager. So again, with the selection structures, because we've seen a lot of trivial examples, so we haven't been doing much with selection structures. That's part of the reason I wanted to work this one in. our scene manager knows what scene is loaded. So we can say get active scene, which is a method. And there's different ways we can check. But one of the things about all our scenes we already used is they all have a name. So get active scene.name, we can see if that's equal to desert. And if it is, if we're currently in the desert, we'll go to the swampy thing. Else if, again, our scene manager object, and look at what scene it's in. And that scene has a name, and we can see if that's equal to swampy. And if it is, well, then we'll have our scene manager call the load scene method and take us back to the desert. That way we can jump between levels. Couple things there that'll be useful. And we do have these in 2D as well. You'll see there's nothing specific to 3 dimensions here. Collisions can happen whether we're in 2D or 3D. So when we start our collision, we also have collision stay and on-collision exit. And all of them will just take in this collision type of data, and then we give it some sort of reference name. Then we can refer to it. And in our case, we're going to use it to go to another scene. And we import that library, and then we have this scene manager object that knows all this stuff about our scenes, which scene we're currently in. Oh, I forgot parentheses. Color coding is nice at times. You can tell when things are the wrong color. The scene manager knows what scene it's in, then we can access other data about the current scene, or the scene manager can load the other scene. Uh-oh. Why doesn't it like that? On line 43. I get a typo in there. Okay, must have had a typo. I have no idea what was going on there. But now if we go back to say our starting point, which was the desert, if we run that, we can go hit the little gateway and move over to the swampy scene, or hit the gateway and get back to the desert. So hopefully you saw there, a lot of stuff is similar. It's just an expansion on what we saw in 2D. A lot of these things are the same. We saw a few new items, but a lot of this stuff is just an expansion on what we saw there. In that version that got erased accidentally, remember we had the nice, better format of separation between graphics and logic. So we had to get an extra step. And instead of going and looking it up, we're able to just use things we know about Unity. Right? That thing that had the animator object, we know it's a game object, so we can just bring that data in and then use it to get our other one, which is in that other script, which I will send out as reference material because that's one we looked at more often. I'll copy and paste this part we hadn't got to yet and send the script out. Just like last time, I'll send out the script, and maybe not the whole file, not the whole project, just that the script we put together. The collisions and scene manager, we haven't seen that before, but you can see there's nothing that says we're in 3 dimensions here or 2 dimensions. It doesn't say what type of game we have. So that is exactly the same as 2D or 3D. So I have a couple ideas on expansion on this that we will get to on Wednesday. Some point between now and then, I will modify our objects here back to the one that we actually walked through in class that I inadvertently deleted. That way it's a copy of what we went through, and I'll send out these scripts. I have a couple ideas on expansions for it, but I haven't completely decided which one I'm going to go with. Probably something that's almost like they'll have like hit points and experience points. So you can see that working with that data is identical to what we normally do in software development business situations, like a payroll calculator where we have a bunch of numbers, hours and rate of pay and tax brackets and all that. For a payroll calculator, controlling that data is the same logically when we get to a game, when we have those numbers representing hit points and experience points and magic points and all those sort of things we want in our game to tell the appropriate story. But I have some other ideas, and I'll probably won't make up my mind till Wednesday morning on which one we're going to look at in particular. But I will modify that to the thing we did in class most of the way through class that I accidentally deleted before now and then we will expand that on Wednesday. Otherwise, does anybody have any questions?
I don't have any questions.
All right, so that leaves us about an hour for lab time. If you have any questions, I will be sitting right here. You can jump back on a Zoom call, or I have a meeting, so I will be on a Zoom call, but I can answer questions in the email and stuff. And at 5 o'clock, when I leave the meeting, I can jump back on a Zoom call to address questions. As always, text messages and Ivy Learn messages make noise on my phone. Let me know anytime you have a question, and I will see y'all on Wednesday, and then we'll do a little bit more expanding on that to see some of the tools we have to work with and stuff. And I will send that script out here in just a moment. Y'all have a good one.
All right, you have a good one, Chris.
Have a good day, Chris.
See ya.